Hello, everyone, and welcome to Cloud Computing Fundamentals, an introduction to cloud and AWS. This educational session is presented by Shri Technology Solutions for informational and learning purposes. In this session, we will start with the fundamentals of cloud computing and gradually understand how cloud technology is used in modern IT infrastructure and application development. We will begin by understanding what cloud computing is and how it is different from traditional IT infrastructure. Then, we will discuss why organizations use cloud computing and understand some of its major advantages. After that, we will explore the three major cloud service models: infrastructure as a service, platform as a service, and software as a service. Once we understand the fundamentals, we will move toward Amazon Web Services, or AWS, and learn about its global infrastructure and key services. Finally, we will summarize the important concepts and answer some common questions. Throughout this session, we will focus on four important characteristics of cloud computing: scalability, security, reliability, and cost-effectiveness. So, let's begin our journey into cloud computing and AWS. Now we will understand what cloud computing is. In simple terms, cloud computing is the delivery of computing services, such as servers, storage, databases, networking, software, and analytics, over the Internet. Instead of buying and managing physical servers, you can access these resources on demand. Key features include on-demand access anywhere over the Internet, a pay-as-you-go pricing model where you only pay for what you use, dynamic scalability, and high reliability with built-in data backup. For example, whenever you use Gmail, YouTube, or Google Drive, you are already using cloud computing. Now let's compare traditional IT infrastructure with cloud computing. In a traditional setup, companies must buy physical hardware, leading to high initial costs, long deployment times, taking days or weeks, and dedicated IT teams to handle maintenance and security. Scaling up requires purchasing extra physical servers, making it limited and costly. On the other hand, cloud computing is highly cost-effective with zero upfront hardware investment. Resources can be deployed in just minutes. Maintenance is managed entirely by the cloud provider, and infrastructure can easily scale up or down based on instant business needs. Why are companies rapidly adopting cloud computing? First, cost savings, eliminating upfront hardware costs through pay-as-you-go. Second, scalability, effortlessly scaling resources based on workload. Third, high availability, ensuring maximum business continuity with minimal downtime. Fourth, faster deployment, enabling faster time to market by spinning up infrastructure in minutes. Fifth, security, offering advanced encryption and compliance standards. Finally, focus on innovation, letting businesses spend less time managing servers and more time building core products. Global giants like Netflix, Amazon, Airbnb, and Spotify rely on cloud to serve millions of users smoothly. To summarize, cloud computing offers total digital transformation. It brings cost efficiency with flexible pricing, dynamic scalability, and enterprise-grade security features like data encryption. Businesses enjoy high availability through automated disaster recovery and global reach to deploy applications anywhere across the world with internet connectivity. Cloud computing also drives innovation, enabling organizations to easily integrate AI, machine learning, and IoT. Ultimately, cloud is not just about technology, it is about transforming how modern businesses deliver value. Now let's look at AWS, or Amazon Web Services. AWS is a leading global cloud platform that provides on-demand computing services. Key benefits of AWS include cost efficiency with pay-as-you-go pricing, seamless scalability, high reliability with built-in fault tolerance, and access to cutting-edge cloud technologies. AWS operates an extensive global infrastructure across more than 240 countries and territories, with over 33 regions and 105 availability zones. This ensures high performance, low latency, and uninterrupted business continuity. Some core AWS services include EC2 for compute power, S3 for secure storage, RDS for databases, AWS Lambda for serverless computing, VPC for networking, IAM for access security, CloudFront for content delivery, and CloudWatch for continuous monitoring. Cloud computing can be deployed in three major models based on business requirements. First, public cloud. Here, infrastructure is owned and managed by third-party providers like AWS, Microsoft Azure, and Google Cloud. It is highly scalable, cost-effective, and accessible over the Internet to everyone. Second, private cloud. In this model, cloud infrastructure is used exclusively by a single organization. It offers complete control, enhanced security, and customizability, and can be hosted on-premises or externally. Third, hybrid cloud. This combines both public and private clouds, allowing data and applications to be shared smoothly between them. It provides organizations with the ultimate flexibility and multiple deployment options.
To help organizations modernize their IT operations, cloud providers offer comprehensive end-to-end services. First, cloud migration, seamlessly moving applications, data, and workloads to the cloud. Second, cloud infrastructure, building scalable and secure environments tailored to business needs. Third, cloud security, providing advanced protection, encryption, and compliance. Fourth, cloud monitoring, offering 24/7 alerting for maximum performance and uptime. Fifth, DevOps and automation, streamlining CI/CD pipelines for faster delivery. Sixth, backup and disaster recovery, ensuring data protection and business continuity. And finally, cost optimization and managed services, helping businesses control spending while cloud experts handle full management and proactive support. Cloud computing is actively transforming industries across every domain. In e-commerce, it handles high traffic spikes and secures online transactions. In healthcare, it enables secure patient data storage and telemedicine. In banking and finance, it powers fraud detection and risk analysis. In media and entertainment, it delivers seamless video streaming to millions of users. In education, it supports virtual classrooms and e-learning portals. In manufacturing, it connects IoT devices and optimizes supply chains. In mobile applications, it powers back-end hosting and smooth scaling. And in government, it helps deliver citizen services securely. Ultimately, cloud computing provides lower costs, high availability, global reach, and continuous innovation for every industry.
Let's explore the AWS Architecture Overview. AWS provides a robust, secure, and highly available infrastructure to build modern cloud-native applications. Key architecture components include the AWS Management Console for web-based access, VPC for isolated networking, IAM for security, and S3 for scalable object storage. For application deployment, EC2 provides compute power, RDS manages databases, WAF protects against web exploits, and CloudWatch handles continuous monitoring. A sample production architecture typically flows from users through Route 53 DNS, CloudFront CDN, and an application load balancer, routing traffic to EC2 instances in a public subnet and RDS databases in a private subnet. This entire structure is guided by the AWS well-architected principles: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability.
AWS offers a wide array of powerful services. Let's look at the most popular ones. Amazon EC2 offers scalable virtual servers. Amazon S3 provides highly durable object storage. Amazon RDS manages relational databases with high availability. Elastic load balancing automatically distributes incoming traffic across multiple targets, while Amazon CloudWatch monitors resources in real time.
For networking and DNS, we have Amazon VPC and Route 53. For serverless architectures, AWS Lambda runs code on demand without managing servers, integrated smoothly with Amazon API Gateway. And finally, AWS IAM controls access securely. Our solution approach follows 5 clear steps: assess business needs, design secure solutions, deploy workloads, optimize performance, and manage ongoing operations. Now, let's discuss AWS Global Infrastructure. AWS operates the most extensive and secure global network, designed to provide high availability, fault tolerance, and ultra-low latency. It is built on 3 core pillars: regions, availability zones, and edge locations. A region is an independent physical location in the world. Each region contains multiple isolated availability zones connected via high-speed, low-latency networks. Edge locations are used to cache content closer to end users, significantly reducing latency. In numbers, AWS spans over 34 regions, 108 availability zones, and more than 310 edge locations worldwide, supporting millions of active customers with over 200 fully featured services. Let's dive into Amazon EC2, or Elastic Compute Cloud. EC2 provides secure and resizable compute capacity in the cloud, allowing you to launch virtual servers in minutes. Its key features include dynamic scalability, built-in security via IAM and security groups, high performance, flexible pricing, and high reliability. The workflow is simple. Launch an AMI, configure instance details, start the compute capacity, and manage or monitor performance as needed. EC2 instance types are optimized for various workloads: general purpose for balanced computing, compute optimized for high performance, memory optimized for databases, storage optimized for big data, and accelerated computing for AI and machine learning. Next, let's explore Amazon S3, or Simple Storage Service. S3 is an object storage service offering industry-leading scalability, data availability, security, and performance. Its standout feature is durability. Designed for 11 nines of durability across multiple availability zones. How does S3 work? You upload data as objects into an S3 bucket, store it securely, and retrieve it anytime from anywhere. To optimize costs, S3 offers versatile storage classes: S3 Standard for frequent access, S3 Standard IA and One Zone IA for infrequent data, and S3 Glacier or Glacier Deep Archive for long-term archiving. Common use cases include backup and restore, media hosting for images and videos, data lakes for analytics, static website hosting, and compliance archiving. Now let's understand AWS Identity and Access Management, or IAM. IAM is the core security service that helps you securely control access to AWS resources. How does IAM work? When a user or group requests access, IAM evaluates defined policies and permissions to grant or deny access to specific AWS resources. Key IAM components include users for individual identities, groups for permission sharing, roles for temporary access, policies written in JSON, and credentials like keys or passwords. Policies can be managed policies, inline policies, or permission boundaries. To maintain security, always follow IAM best practices. Enable multi-factor authentication, apply the principle of least privilege, use groups and roles instead of root credentials, rotate access keys regularly, and audit permissions using AWS CloudTrail. Next, let's understand AWS VPC, or Virtual Private Cloud. VPC lets you launch AWS resources in a logically isolated virtual network that you define, giving you full control over your networking environment. Key VPC components include subnets, which divide your network into public and private areas. Route tables determine where network traffic is directed. An internet gateway enables two-way communication with the internet, while a NAT gateway allows private subnets to access the internet safely for outbound-only updates. Security groups act as a virtual firewall for your instances. A standard VPC architecture places public web servers in public subnets across availability zones, while keeping sensitive databases isolated in private subnets. Common use cases include web application hosting, secure database deployment, hybrid cloud connections, and dev test environments. Finally, let's look at AWS RDS, or Relational Database Service. RDS makes it simple to set up, operate, and scale relational databases in the cloud by automating time-consuming tasks like setup, patching, backups, and monitoring. How it works. Your application connects to an RDS instance using standard database endpoints, while RDS automatically manages scaling, failover, and maintenance in the background. RDS supports 5 popular engines: MySQL, PostgreSQL, MariaDB, Oracle, and Microsoft SQL Server. For deployment, you can choose single AZ for cost-effective non-production, multi-AZ for high availability with automatic failover, or read replicas to scale read-heavy workloads. Key benefits include reduced operational overhead, increased database reliability, and lower total cost of ownership. Security is AWS's highest priority. AWS operates under a shared responsibility model. AWS is responsible for security of the cloud, including physical data centers, hardware, and core infrastructure, while the customer is responsible for security in the cloud, such as data encryption, IAM access, and firewall configurations. Key security features include data protection, identity management, network security using security groups and NACLs, compliance and automated monitoring. AWS offers robust security tools like AWS IAM, AWS Shield for DDoS protection, AWS WAF for web exploits, AWS KMS for encryption keys, GuardDuty for threat detection, and AWS Config for compliance tracking. Security best practices require using IAM roles, enabling MFA, rotating keys regularly, applying least privilege access, keeping systems updated, and continuous monitoring. Now let's talk about Amazon CloudWatch, a complete monitoring and observability service. CloudWatch functions in 4 steps: collect metrics and logs, monitor data in real time, alert when thresholds are breached, and automatically act using SNS or auto-scaling. Key features include real-time monitoring, centralized metrics and logs, alarms and notifications, customizable dashboards, and CloudWatch insights for querying log files. Common use cases involve infrastructure monitoring for EC2 and RDS, application performance tracking, troubleshooting root causes, and security audit monitoring. By implementing CloudWatch, organizations achieve complete operational visibility, faster issue resolution, improved application performance, and optimized costs. Let's combine these services into a real-world scalable 3-tier web application architecture. When a user requests access, Amazon Route 53 handles DNS routing, while Amazon CloudFront delivers static content globally with low latency. Traffic then reaches the application load balancer, which safely distributes incoming requests across Amazon EC2 instances deployed in public and private subnets across multiple availability zones. The application tier communicates with a multi-AZ Amazon RDS database for high availability and automated backups. Static assets and backups are stored reliably in Amazon S3, while the entire environment is continuously monitored by Amazon CloudWatch. This production-ready architecture ensures high availability, seamless scalability, enterprise-grade security using private subnets, cost-effectiveness, and complete observability. To get the most out of the cloud, we follow the AWS well-architected framework built on 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. For cost optimization, key strategies include right-sizing resources, using auto-scaling, scheduling non-production resources, leveraging reserved instances or savings plans for significant discounts, optimizing S3 storage classes, and continuously monitoring costs using AWS budgets. Operational excellence relies on automating infrastructure using infrastructure as code tools like Terraform, centralizing logs, setting up proactive alarms, implementing CI/CD pipelines, and documenting architectures. To further extend your cloud capability, leverage core services like AWS Lambda for serverless, DynamoDB EKS, Amazon SNS, and Secrets Manager. And that brings us to the end of this comprehensive session on cloud computing and AWS fundamentals. We covered core concepts, from cloud deployment models and global infrastructure to essential services like EC2, S3, IAM, VPC, RDS, CloudWatch, and real-world architectures. This foundation prepares you for advanced cloud and DevOps topics such as Docker, Kubernetes, CI/CD pipelines, Terraform, and cloud-native application development. Thank you for watching. If you found this video valuable, please like, subscribe to the channel, and share it with fellow learners. Keep building, stay curious, and I'll see you in the next session.